Hello everyone, how is it going? Hope you all are doing well. Welcome you all on this channel where you will be provided with complete guidance on GATE and engineering service examinations. My name is Shiraz Ahmed. Here is a brief profile about me. So my dear friends, let us start our first course on this channel, that is on fluid mechanics. In this course, my dear friends, we will cover the entire syllabus, and these are the topics that will be covered in this course. We'll be having a series of lectures covering the entire topics as mentioned on this slide. So my dear friends, let us see what are the course objectives. So firstly, हम लोग वो सारे टॉपिक्स कवर करेंगे जो पिछले स्लाइड में मेंशन किया गया था. सेकेंडली, वी विल लर्न वेरियस कॉन्सेप्ट्स, और कॉन्सेप्ट्स का बेसिस क्या है, उसका ओरिजिन क्या है हम समझेंगे. एंड ऑल्सो वी विल सी हाउ दीज कॉन्सेप्ट्स आर इंटरलिंक्ड विथ ईच अदर. फॉर एग्जाम्पल, हम ये देखेंगे कि विस्कोसिटी और डेंसिटी एक दूसरे से कैसे इंटरलिंक्ड है. हाउ डेंसिटी is interlinked with the viscosity, हम ये समझेंगे. As if we learn in this fashion, it will help us to improve our retaining capability, and it will also help us to memorize the formula in easier way. Apart from this, my dear friends, we will also have question practice sessions where we'll be solving some quality questions and previous year questions as well. I have mentioned two books here for reference. You can follow any one of them. So my dear friends, without wasting any further time, let us start our first lecture, that is on introduction of fluid mechanics and fluid properties. These are the topics that will be covered in chapter 1. So we'll first study the definition of fluid mechanics and fluid. We'll see how fluid and solids are different from each other. We'll also learn Pascal's law and various fluid properties like surface tension, viscosity, and specific gravity. So my dear friends, in chapter 1 we'll cover these many topics. Okay? So let us see and try to understand what is fluid mechanics. So as we can see, it is combination of two letters, that is one is fluid and another is mechanics. So we already know what is mechanics. To study various forces and what are the effects of the forces on a body is called a mechanics. So in case of fluid mechanics, it will be the understanding of forces and its effect on the fluid. So this is basic definition, and if you will see what is exactly the fluid mechanics by definition, then it is the study of fluids either in motion, which we'll call as a fluid dynamics, or at rest, that is fluid statics. And we'll also see the subsequent effects of the fluids upon the boundaries. For example, if fluid is flowing inside a pipe, then pipe is the boundary, and we'll see how the pressure varies at the pipe. And another case, if fluid is flowing on a flat plate, then plate is the boundary, and we'll study that what is the effect of that fluid on the boundary. Here I have mentioned various fluid statics applications and fluid dynamics application. So what is fluid statics? It means the fluid is at rest. Fluid dynamics means fluid is moving. We will try to understand the difference between fluid statics and dynamics in subsequent slides. So in fluid statics we will cover various topics like storage tanks, hydraulic jack application, flow measurement devices, and manometer. The various engineering applications for fluid dynamics are breathing, blood flow, and etc. So now my dear friends, let us try to understand what is fluid. Okay, is it clear to you now? So यहाँ पे हम सीखेंगे कि fluid है क्या, what is fluid. So we already know about this solid. So let's suppose we have a solid block and I want to take it out from this position. So उसके लिए हमने क्या किया कि उसको दो साइड से होल्ड कर लिया एंड वी ट्राई टू पुल अप. सो सॉलिड के केस में क्या होता है, लाइक विल बी हैविंग हायर मॉलिक्यूलर इंटरेक्शंस. So if I am applying a force here at this point, this will, due to the large interactions between the molecule, this molecule will pull the molecules below it, and like that subsequently that force will be transmitted till the bottom of this block, and the whole block can be pulled up by a force. But did we ever think of or ever we tried to take the water in this fashion, right? By holding it from here 2 points, can we pull the water? Is it not possible? It is physically not possible at all. Why? Because water is having less molecular interaction as compared to the solid, right? So this is the case of fluid. Water is what? Water is nothing but a fluid. So in case of fluid, due to lower molecular interaction, we will not be able to pull the fluid. So fluid cannot resist a tensile load. It cannot resist tensile load. Can not resist tensile load. It's a very important concept. Every now and then you can expect question from this concept. So why fluid cannot resist tensile load? Because it has lower molecular interaction. That is the basic of this concept, right? So now we learn one thing. The difference between solid and fluid is lower molecular interaction. This is the one thing that we learned from this slide. And this lower molecular interaction will lead us to one concept, that is fluid cannot withstand tensile load. So try to memorize this concept and try to link with your basic concept, that is molecular interaction, and write down this concept. Okay. Now let us see another difference between solid and fluid. Okay. So now let's suppose anyhow I want to take water from here because I want to drink it. Okay. So what I did, I have taken this ladle which is having a depth. So if I'll draw side view diagram, it will be like this. Okay. And I'll be holding from here. So if I dip inside the water will come like this. Okay. So this water, due to the weight of the fluid or water, it will apply a pressure on this ladle. When we multiply this pressure with area, then I can calculate the force that is applied by the fluid due to its weight on the ladle. And this force, when I pull it from here by hand, by a force F dash, then I'll be able to remove the water from the glass. So this is how we take out the water from the glass. So in this slide we now come to know a pressure concept. What is pressure? Pressure is nothing but the force, normal force per unit area. right? This is the pressure. So in case of fluid which is at rest, due to the weight of the fluid, it will apply pressure. So at various points we'll observe pressure at various heights due to the weight of the fluid. This is very important concept. So now we learn, due to weight of the fluid, we observe pressure. So write down these concepts as well. Now next thing, we'll try to understand one more example. We'll take one example. I have taken sugar particles, okay. I have placed inside a glass which is filled of water. Now I want to mix this sugar inside this water. So what we do for that? Okay, देसी तरीका क्या है इसको मिक्स करने का? We'll take a spoon and we will rotate it in this fashion. We'll stir it. Okay. So what will happen? Let us try to observe the mechanics behind this. What is mechanics? Mechanics is the study of forces. So we will study how the force is transmitted from spoon to water. Okay. So I am applying the force here. So the force is transmitted to the spoon. Through its various molecular points, the force will transmit till this layer, right? On the top layer here. Let us take another. So on this top layer, this force will be transmitted through the spoon. Okay. So if we'll observe in this top layer, let's suppose I have drawn this top layer, it will experience a parallel force. So if a force is applied parallel to a surface, what is it is called? It is called shear stress. Right? Force, if we apply a force on a surface parallel to the surface, then we'll find a shear stress by dividing the area with the force. By dividing the force with the area. So as this layer is undergone a force that is parallel to this area, so I'll be getting a shear stress, right? So if I'll see at various layers, it will observe pressure parallel to the area, right? Force parallel to the area. Okay, that is shear stress, nothing but shear stress. So shear stress is transmitted through this spoon on the various layer of the water, and when the water molecule absorb this force, and this force will be transmitted through the various water molecules to the sugar particles, and sugar particles that are away from the spoon, even that will move because of the transmission of the force in the form of shear stress. Okay. So now we will see the mechanics behind the shear stress, like how shear stress is related to various properties. So now let us consider a flat plate on which I am having a fluid. Okay, so this is the fluid on the flat surface. I am also considering a solid body Okay. Now I am applying a shear stress, similar shear stress on both the solid and fluid. Okay. So in case of solid, what do we see? There will be a deformation, right? And it will be undergone a shear strain phi. So as per the solid mechanics, what we can say, tau is proportional to the phi, right? Solid mechanics says that shear stress is proportional to the shear strain as per Hooke's law. Okay. So now I will see the mechanics in the case of fluid. We already know the mechanics in the case of solid, right? That is called solid mechanics. Now we are trying to understand the mechanics in the case of fluid, that is fluid mechanics, when we apply the shear stress, right? Ready? We'll start. So in case of fluid, when we apply a shear stress, it will also undergo a deformation. Okay, let us say the deformation is phi introduced here. We observe that in case of fluid, this phi that we observe is continuously changes. This is observation. So when we apply a shear stress, that is constant shear stress, okay, in that case we observe the shear strain phi and it changes continuously. Okay, this we call as a continuous deformation. This is also be termed as a dynamic deformation because it is changing with time, right? So this concept lead us to what? Shear strain rate, that is d phi by dt, because phi is changing with time. So I have one more term that is called d phi by dt. So fluid mechanics says, as per Newton's law of viscosity, that tau is proportional to d phi by dt. Like shear stress is proportional to the rate of shear strain. This is said by called as a Newton law of viscosity. So this is the mechanics behind fluid. This is the mechanics behind solid. Right? Now we are able to understand the difference between solid and fluid. What is the mechanics behind fluid and what is mechanics behind solid? So tau is proportional to rate of shear strain, which is very important. Rate of shear strain. Try to repeat with me. In case of fluid, shear stress is proportional to rate of shear strain. Okay. In case of solid, shear stress is proportional to shear strain only. Right? So now my dear friends, when we will remove this proportionality constant, right, in case of fluid, okay, let us move to, okay, one moment. Okay. So just now we have seen that tau is proportional to d phi by dt, and when we remove this proportionality constant, what will be the tau? Tau will be equals to a proportionality constant mu will come, that is called as viscosity into d phi by dt. So this is the governing equation for fluid. In case of solid, when we remove the proportionality constant, right, this proportionality constant if we remove, then tau equals to g into phi. What is g? G is the shear modulus. So this is the mechanics for solid, governing equation for solid, and we have governing equation for fluid. Okay, when the shear stress is applied, right? So try to memorize this formula. This formula will be very frequently used in later stage of our lectures. Okay, now we understand why d phi by dt has come, right? So let us try to summarize our understanding. Okay, so we'll call it as a flow box. So we'll try to see what we have learned. So in case of fluid, when we apply a shear stress, what will happen? We'll be having a shear strain that is variable. When the shear strain is variable means dynamic, right? Dynamic deformation. Dynamic deformation means we have d phi by dt. d phi by dt. And this d phi by dt is proportional to shear strain. When I remove the proportionality constant, then I will be having dynamic viscosity mu. Okay, so we have learned this thing in this lecture, right? Till now we have learned this thing. And in case of solid, we already know that tau is equals to g into phi. Okay. So now my dear friends, the things that I have explained you are written here in words. So what is fluid? It is a substance which is capable of flowing or deforming continuously, right? That is dynamic deformation. under the action of shear force. So this is the hardcore definition of the fluid. Okay. If we'll see in case of solid can resist shear stress for sure, but with static deformation, means phi will be constant for a particular shear stress. Okay. So in solid, the deformation, that is phi, is almost constant, while in case of fluid, when shear stress is applied, the deformation will change with time. Okay. So now my dear friends, let us see and observe what will happen when various load is applied in case of solid and fluid, right? So let us consider a solid here. Okay, and I have a fluid here, and now I am applying a tensile load. So what will happen in the solid? Solid will resist that tensile load, while the fluid cannot resist. Why? I have explained in just few minutes back, because molecular interaction is low. Second, compressive load. So in case of compressive load, solid will resist compressive load, fluid will also resist, and we'll call it as a pressure, right? That compressive load, if we divide with normal area, okay, then it will be pressure. And third is shear stress. When we apply shear stress, what will happen? In case of solid, we'll have static deformation, that is phi will be constant. In case of fluid, we'll be having dynamic deformation, and phi will be variable. Okay. So these are the things that we have learned till now. Okay, my dear friends. If you have any doubt till now, you can ask in the comment section of this video. Okay. So whatever I have explained you just now are written here in this slide, and this concept is very important and will be used in next lectures. And my dear friends, you can expect anytime questions from this topic. Okay. So let us try to summarize what we have learned. So in case of solid can resist both tensile, compressive as well as shear forces under static condition. Okay, this we already know. Next, now we will see what will happen in case of fluid, right? Just now we have learned, when there is tensile load, it cannot resist, negligible resistance. When there is compressive forces, it will have static deformation. When we'll have shear force, then fluid will have dynamic deformation. Okay, so from where we can conclude that when we talk about fluid statics, it means there should not be dynamic deformation, right? Am I right? So try to interlink the concept. Now we are interlinking the concept. This is what I explained you in the very beginning. Okay, when we talk about fluid static, it means dynamic deformation is not there, right? When dynamic deformation is not there, means d phi by dt will not be there, right? When d phi by dt is not there, means shear stress is 0. So try to understand this thing by flow. So in case of fluid static, shear stress is 0. We all the time we say, we know, we learn, we memorize this concept, right? For fluid static, shear stress is 0. But why shear stress is 0? This is the concept. This is the interlinking. Okay, this is called interlinking of the concept. Now it will be easier for us to understand and to memorize this concept, right? So now my dear friend, let us begin to our next topic, that is Pascal's law. So what Pascal's law says, that fluid under equilibrium state, so when the fluid is under equilibrium state, means hydrostatic, fluid is not moving, okay, A pressure change at any point in an enclosed, incompressible, note this point, enclosed, incompressible fluid is transmitted undiminished to all points in the fluid. Let us understand this by taking an example. Okay. So let us consider this example. Okay. So I have this pipe. Okay, here is a piston. Here also I have a piston. Okay, this is enclosed. Okay, this area is enclosed. And now I fill this with water or some fluid. Okay. और हमारे पास एक मैकेनिक है, उसका नाम है चंगू. So what he wants to lift a car that is placed on this platform. Okay, this is a car. So what he wants to do, चंगू क्या करना चाह रहा है, इस कार को लिफ्ट करना चाह रहा है. तो उसने क्या किया, कार को यहाँ पे रखा. चंगू होशियार बंदा है, ठीक है, बेवकूफ़ नहीं है, वो बहुत होशियार है. उसने कार को यहाँ पे नहीं रखा, उसने कार को कहाँ पे रखा, यहाँ पे, और खुद यहाँ पे बैठ गया. ठीक है. तो जैसे ही यहाँ पे उछल के इधर से ये यहाँ पे बैठा, देयर विल बी चेंज इन प्रेशर हियर, डेल्टा पी, बिकॉज ऑफ द वेट ऑफ दिस चंगू पर्सन. सो व्हाट पास्कल्स लॉ सेज दैट द प्रेशर चेंज is transmitted undiminished, okay, in an enclosed incompressible fluid. So this is enclosed fluid, right? There is no leakage. This is incompressible. Let us assume it is incompressible. Okay, so these two things that I have told you is there, right? It is enclosed and it is incompressible. Okay, and the fluid is at rest, so it is hydrostatic. ओके. सो उसके बाद क्या किया, चंगू कूद गया यहाँ पे. सो यहाँ पे कूदने से क्या हुआ, यहाँ पे प्रेशर, एडिशनल फोर्सेस आएंगे उसके वेट के, उससे एरिया को डिवाइड कर दोगे तो प्रेशर चेंज आ जाएगा. सो नाउ पास्कल्स लॉ सेज दैट दिस प्रेशर ट्रांसमिटेड अनडिमिनिश्ड टू एवरी पॉइंट, हियर 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 एवरीवेयर, हियर 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 हियर. सो हियर ऑल्सो इट विल बी ट्रांसमिटेड एंड हियर द प्रेशर चेंज विल बी डेल्टा पी. सो लेट अस consider the weight of the changu is W1 and weight of the car is W2, and here the area is A2 and here the area of the piston is A1. Okay, so if we will try to balance the force, what will be the force balance? W1 जो change in pressure होगा W1 upon A1 होगा, right? वो किसके बराबर होगा, डेल्टा पी के. यहाँ पे जो चेंज इन प्रेशर होगा डेल्टा पी, वो इस पे एडिशनल फोर्स लगाएगा, उसकी वैल्यू क्या होगी, डेल्टा पी इंटू A2, और वो किसको बैलेंस कर देगा, कार के वेट को. ठीक है. इस इक्वेशन से हमें क्या मिला, W1 इक्वल्स टू डेल्टा पी इंटू A1. दूसरा इक्वेशन क्या है, W2 इक्वल्स टू डेल्टा पी इंटू. अब देखो होशियारी, देखो ये बैठा है कम एरिया वाले के ऊपर और कार को प्लेस किया है ज्यादा एरिया वाले के ऊपर, राइट? सो A2 इज मोर, A1 इज लेस. ओके, सो आई कैन से फ्रॉम दीज टू इक्वेशन दैट W1 इज लेस देन W2. अरे वाह, चंगू का कम वेट होते हुए भी ही इज नाउ एबल टू लिफ्ट अ कार ग्रेटर देन हिज वेट, राइट? He is able to lift a car greater than his weight. So this device, what he called this device is hydraulic jack. So by applying a small force, we are able to lift a higher weight car or dumper or any other devices, right? So this is one application of the Pascal's law in the hydraulic jag. So now we understand the concept, and we understood what is Pascal's law. We have seen what are the assumptions in the Pascal's law, that is fluid should be enclosed and fluid should be incompressible. So these are the assumptions, and fluid is hydrostatic. So these are three assumptions in the case of Pascal's law. Try to memorize this thing. What are the assumptions of the Pascal's law? Assumptions. I will write down here for you. So first assumption is fluid should be enclosed. What is second assumption? Repeat with me. Hydrostatic. What is the third assumption? It should be incompressible fluid. So these are the three assumptions in case of Pascal's law. Try to memorize this thing. So if these things are satisfied, then a small change in the pressure at anywhere in the fluid, the same pressure change will be observed throughout the fluid. This is the Pascal's law, right? This is another definition that we'll sometimes say. Okay, the pressure applied at any point of the enclosed liquid will be transmitted equally in all directions through the liquid. Okay, so this I'll say that if I have a fluid here, enclosed fluid, okay, and I'm changing pressure here by delta P, so in all direction the same pressure change will observe. Okay, so this is what this definition is saying. So now my dear friends, we will see the mathematical representation of Pascal's law. Okay, we'll see the mathematical representation of Pascal's law. Okay, so what is this? It says that the change in pressure due to fluid height is rho g into delta h. Okay, so let us consider a fluid column. Okay, so I have a fluid column here. And I am considering 2 points in this column, vertical 2 points. Okay, point number 1 and point number 2. The height between these 2 points is delta h. So mathematically it says that the pressure difference between these 2 points, delta p, is nothing but rho, that is density of the fluid, into g, that is acceleration due to gravity, that is downward, into delta h, that is difference between the height difference between the 2 points. Okay, so this is what this statement says. So now we will see try to observe point 1 and point 2, where the pressure will be more, point 2 or point 1. Try to think where the pressure will be more, my dear friends. Very simple question to you, to all of you, where the pressure will be more. Try to use the concept that I have told you earlier. Try to use that concept. Where the pressure will be more, at point 1 or point 2. Think for a moment. So now I'll explain where the pressure will be more. In previous slide I have explained you the fluid will apply pressure due to its weight, right? in case of hydrostatic. So due to the weight, there will be pressure. So if I see point 1 and point 2, there is some fluid in between, right? And that fluid, due to its weight, will apply additional pressure on 2. So it means pressure at 2 will be more. So delta P is nothing but P2 minus P1 equals to rho G delta H. Or I can say P2 equals to P1 plus rho G delta H. Right? Okay. So this is one formula that we will have to memorize. But I'll try to simplify this formula. Okay. I'll try to simplify for you. Okay. So now let us take one more slide here to explain you. Okay, I'll take one more slide to explain you. So now this is now I already know. Okay, so now let us consider a bucket filled of water. Okay, and similarly I have 2 points vertically downward, two vertical points. Okay, and the height is between them is h, not delta h. Now I will consider h. Try to memorize the formula in this fashion. Okay, so as per Pascal's law, what I can say, the pressure at 2 will be more, right? Because of there is weight between these 2 points. So what will be pressure? P2 equals to P1 plus rho G, because P2 is more, right? So if I want to find pressure at point 2, which is below the point 1, then I'll have plus term, right? When I want to pressure at such a point which is above to another point, like I'm moving up, then it will be P2 minus, so minus term will come. So this particular thing will be used so many times in columns, right? So let's suppose I have a column here. Okay, and here is a fluid. So now I am moving down by h. So what will be the pressure here? If I pressure here is P, so what will be the pressure here? Density is of this fluid is rho. So pressure here, that is P dash, will be P plus rho GH, because I am moving down. So when you move down, plus rho GH, right? Because weight will come additional. Now this is P horizontal, the pressure will be constant. Okay, horizontal, the pressure will be constant. This concept we will learn in next slide. Okay, why in horizontal the pressure is constant? Okay, so if I know the pressure here, it is P dash, I want to find pressure here, that is P double dash. So what I will do, P double dash equals to P dash. Now I am moving up from down, so it will be P dash minus density of the fluid G into what is the height. Let's suppose this height is h dash into h dash. So you try to understand in this slide when we will be having plus rho gh and when we will be having minus rho gh. So this is what I wanted to explain it to you. I hope now it is clear to all of you, right? So now let us try to understand one more concept, like why in horizontal the pressure is constant, right? This is another definition of Pascal's law. Pascal's law also mathematical expression of the Pascal's law. So what is mathematical expression that is there? Delta P equals to rho G delta H. Delta is the vertical height, right? So if I'm moving in horizontal direction, right? So there will be, I'll cover no vertical heights. If I'm moving from point this P1 to P2, right, in horizontal completely, then there is delta H will be 0. So what will be the pressure? There will be no pressure difference, means P1 equals to P2. So in hydrostatic condition where the fluid is incompressible, okay, and what are the assumptions? Incompressible, hydrostatic, and fluid is enclosed, then the pressure will be In horizontal direction, the pressure will be constant. The pressure will vary only in the vertical direction. Why? Because the acceleration due to gravity is downward. And that is the only acceleration that will create the pressure difference due to weight of the fluid. Okay, understood? So now we can say, as acceleration due to gravity is downward, the hydrostatic pressure due to weight will have effect in vertical direction only. Right? This is what I wanted to explain to you in this slide. Like horizontally, the pressure will remain constant because acceleration due to gravity is vertical. When acceleration due to gravity is vertical, in this formula delta P equals to rho g delta H, right? Delta H will be 0 in horizontal direction, so there will be no pressure difference. This formula will be valid only in vertical direction. Delta P equals to rho g delta H. Okay, hence perpendicular due to gravity, that is horizontal direction or acceleration, the hydrostatic pressure remains same. So what this statement says, that in a bucket full of fluid where the acceleration due to gravity is downward, okay, perpendicular to acceleration due to gravity, right? This is the perpendicular line. Will be having isostatic pressure line, means pressure will be remain same at each and every point here. And if I want to find the pressure differences at vertical lines, how the pressure will be calculated? P dash equals to P plus rho g H or P minus rho g H, depending upon where we are moving. If I am moving from top to bottom, then the pressure will be more, and so I have plus sign. If I'll move from bottom to up, then the pressure will be less, so negative sign, P minus rho g H, right? If you have any doubt in this concept, it is very important concept which will be used later on. So please, if you have any doubt, you can ask in the comment section below. Okay, my dear friends. So one more thing that I'd like to explain you, that we'll use in later stage. That is, let's suppose what happens if I have a gravity that is inclined. So I have a bucket full of water. Okay. But the gravity is, or the acceleration is inclined. Right? In that case, the isostatic pressure line will be perpendicular to this g dash, that is acceleration due to gravity. Okay. And how the Pascal's law will be written here? That is delta P, that is P2 minus P1 is rho g dash into H. Right? So if I want to find the pressure difference between these 2 points, how we can find? This is P2, this is P1. P1, P2 will be more because it is downward and there will be weight of these fluids in between that. So this weight will create additional pressure. So P2 equals to P1 plus rho g dash into the height difference between P1 and P2, that is H. So P2 minus P1 equals to rho g dash into H. This is the very important concept. You can expect questions anytime from this. Okay, in the comment section of this video. So now my dear friends, this is all from our first lecture. I thank you all for watching this video. And if you have liked this video, share it with other students as well. We will have the other topics covered in next lectures. Thank you all.